Can I tell you something? You're the first person in the world to know this story, apart from my wife, my daughters, and the Norwegian friend. So it's like actually unique. I know people have wondered where did Teletext come from and who the inventor is and everything, but I never told this story before.
I'm Carlos, and welcome to Teletext People from Byte High No Limit. Byte High No Limit is a podcast looking at the social history of technology, speaking to people and getting their stories. In this episode, we speak to John Adams, who is the inventor and creator of the medium of teletext. I started by asking John how he actually got into electronics in the first place.
How did I start? I started maybe at the age of 7 years. I built a crystal set. It was like a radio set that has no transistor, no valve, a very primitive crystal set. And I built one at probably age 7. And from that moment on, electronics became my main hobby. By the time I was 12, maybe, I was building radio control equipment, building the electronics and building the servos, everything. That would have been 1960, early 1960s. The crystal set was in the 1950s, but the radio control equipment was in the 1960s and built with valves because transistors had only just been invented. Probably my best piece of electronics in those days was used a valve from a hearing aid and a red spot transistor I bought for 15 shillings down in Ipswich, center of town. 15 shillings was an awful lot of money in those days, but I bought a red spot transistor.
Yeah, 15 shillings would certainly stretch the bank then.
And I won the school physics prize with it.
Oh, excellent. What sort of size are we talking for that transistor?
The transistor is the same size as more or less what you buy now. It was a can, small can, very small can transistor. And the valve, I still have it. I could send it to you. I could show it. I'd send you a photo.
Excellent. And you went to Ipswich for that. Was that your local, is that where you lived?
That was where the local kind of electronics shop was.
Did you have far to travel to get there?
No, just
oh, right. So I live in Clacton on Sea myself, so Ipswich.
You didn't?
Yeah.
Oh, no. Clacton.
Yes.
Oh, wow. We used to go there, the weekends.
Oh, right. Yeah. I grew up in Jaywick.
Oh, you are joking?
No. Yeah.
I can hear the accent there. Oh, God. I went to university in Manchester, and I did electrical engineering and electronics. And I went to London in 1970. I went to 6 interviews and ended up with 6 jobs. So I was very happy, but I had a passionate interest, absolute passionate interest in neural systems, artificial intelligence, but more than the AI they have nowadays. This was in reproducing neurons by electronics, and therefore being able to make a neural network. That's what I wanted to do. But I knew that I had to get into a massive amount of into extremely big systems. And so of the 6 jobs, there was one company offering the possibility of working in digital electronics, which was at its birth. This is the very beginnings of digital electronics. And so I joined them, and they were working on computers, right? And for me, it was a way of getting into the type of electronics I wanted to do. And they were doing, they were planning, this is Philips, they planned to get into what was called the replacement of teletype machines. The photos I sent you, that was my job, to make a piece of electronics to replace that. And I did it with 2 other people in Mullard Central Application Laboratories in Mitcham, Surrey. And it was my job to do the building. So we put this together, and it was used. Do you know what shift registers are? Shift registers.
It's a term that I'm sort of like I'm familiar with, but I'd love you to explain it.
Okay, this is not teletext. This has nothing to do really with teletext, but it is what I worked on to start with. And the shift register, these came from electronic arrays in the States. I guess you know Bob Noyce, right? Bob Noyce at Fairchild Semiconductor. He had invented the integrated circuit. And so Fairchild was making integrated circuits, the very, very beginnings. This is a chip with like 2 transistors on it. And electronic arrays was a spin-off. And they were very successful at the beginning, and they produced these things called shift registers. We're talking here in 1970, when there were the amount of digital electronics and chips almost did not exist. In 1968, Bob Noyce, who had been the founder of Fairchild and the inventor of the chip, started a company called Intel. And Intel started making a thing called a DRAM, dynamic random access memory. So they were building those. Anyway, in order to make this teletype replacement machine, we had to have some means of seeing data. So we put that on a thing called a monitor. It's like a television set, basically. And then we had to develop the electronics that would make the text. So when we'd finished it, it was in fact me that built it, and I built it in absolute record time. It was meant to take like a couple of months, and I built it in a few days because I built the electronics all my life, right, basically. So I put this thing together. I was a very young, straight out of university engineer. And there were 1 or 2 people in the laboratory that did not like such a young person who had done nothing at Mullard, working on what was at the time the real fancy project. And when I built this thing so quickly, it didn't make these people very happy at all. Well, I built this thing, and then I won't say the name of this person, right? Though I remember his name very well. He came over and he started mocking me about this thing I built, and it won't work, So I'm saying, yes, it will. Look. And anyway, he says, it'll take you a month, and now your real work starts. It's making it work. That's the real work. And he was being a little bit unfriendly, a little bit unkind. So I became somewhat annoyed. And I said, yes, it will work. He said, oh, you'll be a month making that work, at least a month. And other people gathered round, and they're all there saying, yeah, it'll take you a month to get that to work. And I became so irritated that I said, when you people walk in tomorrow morning, that will be working. And they went off home laughing, stupid young student, you know. And so I started working really hard. It gets to 7 o'clock. And I said, oh my, I'm going to be late for, it just won't work. And it gets to 9 o'clock, nothing's happening. Gets to sort of like 11 o'clock, say, obviously I'm having no supper tonight. And I'm working and working. It gets to 2 o'clock in the morning, nothing. And I work all through the night. And at 6 o'clock in the morning, there's a flash on the screen. And it's the beginning of text. I said, it's working. I'm there. By 7 o'clock, I got text everywhere. By 7:30, it was perfect. So I said, right, I'm not going to admit to those my colleagues that this it took me the whole night to get this thing working. So I walk out of the building. I go to a local one of those old, like, you know, where you buy a cup of tea in the morning, you know. Right into the little bar, bought a cup of tea, bit of toast, and then walked into the laboratory normal time, you know. Walked into the lab, and there's all my colleagues. And I say, do you want to see the text, the terminal working? They look a bit surprised. I switch it on. Silence. Absolute silence. And everybody's looking at it. And, oh my, yeah, it was like, and you have to understand, in those days, you know, like there was no text on screens. There was no PCs, no phones with screens. To see characters, text on the screen that you could change with a keyboard was revolutionary. And so people came from far and wide to see this thing. That was not teletext. This is just a data entry terminal. And it used a 32 electronic arrays, 32-bit shift register. It was by 4. 32-bit by 4, 2 of them running in parallel, and they scan round. They circulate round as the beam scans the TV, the TV screen. So anyway, there it was, and we'd gained a month. My boss and myself, that we gained a month because it was working so quick, and we just sat around wondering what to do with it. Well, a few days later, the same person who had been unpleasant came over again. And he said, well, so it works, you know. He said, but it's totally useless. Our job is to sell Philips televisions, the screens, not the television set, the screen, the tube, the old shadow mask tubes. Biggest manufacturer in the world wanted to sell more of them, right? And they built them, they made them in Mitcham, some of them. So the guy says, our job is to sell more television tubes. There's 5,000 computers in Britain because they were big, they were rooms. So if you're lucky, you're going to sell 5,000 terminals, maybe 10,000. Philips wants to sell millions and millions of screens. So it's rubbish. So my boss and myself sat down and we've got a whole month here. What are we going to do? And my boss said, he's not much interested. He doesn't care that they're going to scrap the project because there's not enough to be sold. But I said, no, I love this project. So he started thinking, and you can see his patent. He said, I'm going to try to improve the characters. So he invented a thing called character rounding. You can get his patent if you want. And me, several days later, the same guy came over again to, like mock me a little bit more and say, like, time to end the project, Ben, And I said, like, we're going to sell billions of these. We're going to put text on people's televisions at home. We're going to send information to people's homes, and Philips will be able to sell not millions, billions of TVs, but people will want to have information at their homes. And he laughed, and other people said, what a stupid idea. But then after a while, a very senior person in Mullard said, that may be not such a stupid idea. So they invited the BBC to come and have a look at it. This is 1970. So in 1970, we showed a team of people from the BBC this text machine. It was a data entry terminal. It was not teletypes. Then Philips decided that there may be something in this project, and they started. They decided to fund more development work, and I was given the job of doing it on my own. Just so my effort had bought me. I was probably the youngest kind of project leader, if you like, but wasn't given the title, but in Mullard history. So I had this project, and it was to make data entry terminals for computers on a big scale, bigger ones, much bigger. But all the time had in the back of my mind and people around me the idea that maybe we're going to use this for we're going to make a system to put information on home televisions. And then in 1971, the BBC phoned up, I don't know who, people inside of Mullard in the head office, and said, like, they can't get their text machine working, and that they like the idea, and could Philips design a system? So I was given the job Friday afternoon at 3:30. Design a system for Monday morning. And I said,
well, that's no problem for you, because you can develop a whole system in overnight.
well, a big question. You're right. I was by that time building machines with 80 characters on the line for computer entry, right? You remember the old data entry terminals that computers used to have. So at that time, I was already designing 80 characters per line. I sent you the picture of the character, the iced tea, I think it says. The reason is it shows the interlacing. I don't know, the old 625 television used interlacing. That's when the beams, the beams that scan, the electron beam that scans to create the pictures, in order to double the number of lines, they would write a line, scan a line, 625 divided by 2, 312 lines. And then the second scan goes in between the lines. So you end up with 625. And so the first big issue was, how do I get the information to the television? How do I get it there? And the only place that seemed sensible was during the frame flyback. So in the frame flyback, I didn't know how much of it I could use, but I happened to be in one of the world's best television design places. So it was 3:30. I popped over to the other side of the building where the people who do all of the drive circuits for the television, and they're saying there's like 12 lines of it that I can use. But if the television's out of adjustment, then maybe only 2 or 3. So I then go back and I speak with a pretty senior guy. He ran the computer group, this guy. He wrote a book on teletypes if you want to read it.
Oh, what was his name?
Gerald Crowther. Gerald Crowther.
Right, okay. I don't think I have his book in my library, so I'll hunt that one out.
A book by Gerald Crowther and Ivor Cohen.
Right, okay.
Yeah. I don't know if it's available publicly. I'll tell you what, I'll send you a picture of it. I have the book
Please
here.
do.
Now, Gerald Crowther never claimed to invent teletext. Because he said he inherited it. That's true, because I joined his group. So he inherited it. So he doesn't ever speak of the story of the beginnings of teletext. He speaks of the story of what he did with it later on. Anyway, so Gerald Crowther, I say to Gerald, Gerald, I think I can get like 60 characters and make them big enough people to see all these stuff. And he says, John, this is going to have to work on Granny's television. And I said, oh my God, what you mean one of those ones which when you turn off has a dot? Do you remember those? You turn off the telly and there's a dot on them. And he says, yes, one of those. But it's 20 years old and totally out of alignment. It's a mess. It's got to work on. And he says, also, John, the man in the street's going to have to be able to buy these. This is going to have to be like low cost. So it was a massive Sudoku puzzle I had. How to piece together something that wouldn't cost much money. But there was something had happened. Intel had announced the 1103, probably the most important memory in human history, memory chip. It was a 1,000-bit dynamic random access memory, 1103. By 1,000, that's like digital designer talk. I don't mean 1,000, I mean 1,024. Yeah. So part of this Sudoku puzzle was if I've got to get the price down cheap, I cannot use shift registers. And if it's got to go on Granny's television, I cannot use 80 characters. Can't even use 60. This is Granny's TV. It's also small. So it was a puzzle, a big puzzle. So I went to my best place for thinking, and it was not It was not a silent place. It was, this is true. I went to a honky-tonk pub in London with sawdust on the floor. And I went up to the bar and said, I would want half a pint of Guinness, not a pint because a pint will cloud your thinking. And I sat in the corner of this pub with my half pint of Guinness, puzzling it all out. How can I do all of this? Get it all low cost, work on Granny's TV, and from the point of view of the electronics, shift registers, all these things, static memories, everything was out. It had to be low-cost memory. The lowest cost memory projected on the planet was going to be Intel's 1000-bit 1103. Philips had started making the GYQ 101. GYQ 101 was similar to the Intel chip. They were building that in Southampton. They were starting to work on it. So, you know, from a cost point of view, the lowest cost memory available by far was the Intel 1103, and I would need 7 of them. But they're 1024 bits long. If I put on 2, it was going to be expensive. Plus, 1,000 characters on the screen is actually quite neat. So then I started thinking, that's why I sent you that picture. I had to put on a number of characters on a row that were going to fit. And the height is completely and utterly limited because you cannot change the spacing on a scan television. It's determined by the 625 lines that are available. So if you look at the numbers, in the end, it looked like 40 characters long, looked sensible. And then if you look how you're going to generate the character, if you go below a 7x5 matrix, you end up with quite ugly characters. If I went above, because of the height restriction, you won't get enough rows on your television screen. So the compromise was to use a 7x5 basic matrix, which becomes 7x9 because you've got the Ys and things to drop down. And then there's other considerations like that has to be contained in a ROM. The ROM's got to be fast enough. And in fact, there was ROMs fast enough, even in 1971, to allow the access to get the information. And then the RAM had to be fast enough. There's an awful lot of thinking behind it all. I'm saying it quite quick, but I was very much in tune with the technology because that was my job for making display terminals for computers. So it was a heavy piece of work, and we sent a proposal to the BBC. And then because Philips didn't want to patent the whole concept. And this is, I didn't like it. I was quite opposed to it, but they wouldn't patent it. And you know, like if you're an engineer working for a big corporation, you sign away your rights for anything you design. They didn't want to patent it. They wanted to make it available to everybody and anybody because they didn't care about the CFAX or Teletext chips, which was a mistake on their part, actually. What they wanted to do was sell tubes, television tubes, the 625, the famous old shadow mask, which one of the world patents, the fundamental patent on how to make a TV tube, was owned by Philips, the shadow mask. So I put together this design, specified a couple of lines in frame flyback for the information, specified three-dimensional CRC. You know what that is, cyclic redundancy coding. So that was going to consume quite a lot of the DRAM. So in the original specifications, I said like 40 characters on the row. That's what it is. Quite honestly, I left Teletext early on. Philips wanted me to work on their microprocessors. So I worked on microprocessors. Philips, when became nervous, they as one of the world's great electronics company did not have much digital technology. They didn't have a microprocessor. So they purchased Signetics. Signetics was a little company that sprung up out of California in Santa Clara. And they brought out a microprocessor called the 2650. And it was meant to compete with the Intel ones. Intel came out with the 4004, that was the first one, designed by Ted Hoff. Then they came out with the 4040. Then they came out with the 8008, then the 8080. But all of this was going on, and Intel was beginning to dominate the world of electronics. And Philips, huge and very wealthy company, said, we will buy one of these Santa Clara startups. So Intel was far too expensive. So they purchased Signetics. And Philips put me on working on microprocessor design. This is not using them, this is designing the insides. So I did that. I did that fairly early on. About I started in before Philips bought Signetics. But so Philips kept using me on things which were like at the front end of the technology, if you like. So Teletext, I left Teletext. Well, I guess Teletext was my baby till 1976. So I guess, I mean, that's pretty much the basic story. There's a number of other things behind it all. At the start of Teletext, the very start of it and the start of the terminals, the Philips or Mullard kind of like display or text generating group, or we used to call it a VDU, putting it on the screen, visual display unit. The entire group was one man, because the target was to sell to computers, and like this colleague has said, there's not many of them. So it was my baby from 1971 onwards, terminals, and I was you can say I was the lead designer. Basically, I was the only one. But by 1973, I was joined by a guy called Ian Hampson. He's made one or two broadcasts about Teletext story on the radio. Yeah, and he was on the anniversary of the 50th, the celebrations for CFAC's 50th. There's something behind all of this that maybe you should know. I was not like the ideal person for presenting to customers. I was long-haired, lived on a boat in the middle of the Thames, and did not go into work on time and didn't leave work on time. I would stay till 12 o'clock at night if I was doing something interesting. But I saw those. I was a little bit unruly, if you like. And as much as Gerald Crowther, the same man, tried to get me to behave myself, I wouldn't. So they gave me a colleague. And then there was many other people joined the Teletext group. It became big. It became big. There was a specialist in, well, the CRC code, Phillips didn't want me to work it all out. So the CRC coding was done by a girl called Sandra. It's a big team in the end. And then after I got into designing, well, the chips inside, you know, the first design of Teletext was designed to be on a chip, you know, because Gerald Crowther wanted me to make this thing low cost. The only way the amount of electronics to make a teletext receiver is pretty big if you don't use chips. It's like big. In those days, you could get a chip, the 1103 for memory. You could get a ROM. One or two companies made the ROM, the read-only memory. That is, you put in an address and you get the dot pattern for the row. It stores the characters, I guess you know. So you could buy ROMs that were fast enough. You could buy, but that were the chips. There wasn't chips to. I could not use Intel had brought out the 4004 microprocessor. I could not use that. It's too slow, far too slow, and it was not able to handle the complexity of driving the speed and the drive you needed to generate characters on the screen. It was just impossible. So that was all done in TTL, Texas Instruments, TTL. And in those days, all of the kind of glue electronics, the glue, was done with TTL from TI. Well, actually, I have to be nice to Phillips. They also had their own TTL. So, but Phillips, from day one, seemed to like the idea of CFAX. I call it CFAX because that was the first one. But they never wanted to patent it. But the character rounding was patented by John Gilliam. That was like... It's now taught in Spain. I don't know about Britain, but it's taught in Spain. Like, if you go to university and study what they call informatica, one or two friends here said their sons come back from university and said, "Dad, your friend was mentioned in the lecture today." It's not going to be important in the future for teletext, but people know it, yeah. But because it's one of the early information systems, you know, electronic, I mean, like, fundamentally, everybody's television had to have this piece of electronics stuck on it. And if you read on the internet, they say, why did the designer, like, isn't he an idiot, make the characters so chunky? The reply to that is, you try and do this, the 1970 technology on a budget. Chunky is why it's chunky, because it was the only way of getting that number of characters and keeping the price low. And anyway, if you look at how the old TVs scan, you're youngish, yeah? No, I'm just wondering. You saw the old 625 TVs, right? Yeah, how they scanned, right? 625 lines you've got. So there's not much you can do. Like if you were to buy a PC or a phone now with 625 vertical pixels, you say piece of junk.
You'll send it back. You'd go, someone smeared Vaseline all over my screen. What's going on?
Yeah. But that's all I had.
Mm-hmm.
And then you've got to get the geometry fairly right. Like you can squash the characters up, but I mean, I was lucky that 1024 works out quite nicely with 40 characters, 24 or 25 rows. If you use 25, you've only got 24 bits left over for your cyclic redundancy. But then later on, when the future designers of Teletext, they could put separate memory on, right? They weren't restricted, but me, I had to keep the price down. So that's why I basically specified 24 rows, 25, 24. That leaves a few bits over to put your CRC code in. Right?
Well, it became the industry standard for the microcomputers that followed 10 years after, because people were using the standard CRT because, to keep the prices down, they weren't using a dedicated monitor. And
well, that thing was used. That was used in a lot of other systems, Prestel, and inside of the group that in the Teletext group or the Teletext area. Look up the Central Application Laboratory of Mullard, because in there was other people. There were spin-offs from the Teletext project, like Prestel, and then the French. The French had a telephone system where you could see people. I used to have to go to France because they were trying to design. They wanted display units, and it was me that was helping them with the design of the display units so that they could have people on the telephones. Like Philips didn't. They didn't like me as the front man, I guess, with the long hair. I don't know what I did wrong. And living on a boat. There's another guy you can speak to. Speak to Ian Hampson. He was my colleague, and he's one of two things. He's you'll see him. You'll see him the on the program he did with the BBC. You'll see him with a thing called Mandy. Mullard Alphanumeric Display System. Mandy was designed by me. It was a very complicated display system. And the electronics inside it is very complicated because you can change the number of characters per row, the number of rows is totally flexible. And he and I worked on Mandy until 12 o'clock at night for several months. He tells the story, like this awful time in his life when he worked till 12 o'clock. And I went over to see him and he's telling me like an exceptional time in his life when he was working till 1 o'clock in the morning. And I'm going, was it? Because I do that. If I got an interesting thing, I do it till 1 o'clock. I don't stop, if I like it. So, but for him, it was a bit unusual because we had to solder, put it all together. I was working like crazy on the design because Ian and then a group of commercial people went all over Europe trying to sell the Philips computer terminal. And they didn't want me to go, I guess, because of the long hair or whatever. Philips put me always on the next technology. So I didn't ever stay very long with anything. So with Teletext, you'll know Teletext much better than me. I left it at the initial design stages. I did a proposal that was sent to the BBC, also to the, was it called IBA? We sent it to one of the people. And I then stayed like the mother, if you like, of all of the display systems because I knew it better than other people. But I also did the microprocessors and things. I've always been like, if you like, you could say extremely lazy in that I don't like to study things. And my way out of not having to study is to invent something, like come up with a new idea. Then you don't have to study to find it out, And it's always been my way for the whole of my life. So coming up with new ideas is actually second nature, doesn't it? You sucked out of me stuff that I didn't really think I should share, like designing teletext in a honky-tonk bar in London. But the fundamental, when you've got a design problem, it's like a Sudoku puzzle. I don't know if you do those, but it's like one of the hard category. You've got to fit together everything, and all of the jigsaw I fitted together. Then there's an awful lot of details that come afterwards, like how do you put the text stream into the frame flyback? How do you actually do that? There's a lot of, but the concept and the basic block diagram was done. And that was where the 40 characters comes from, the 25 rows. And there's something special about a 1024-bit memory. Do you know what that is? What's special about the 1024 is that it's 32 by 32. Now, if you do 32 by 32, you can make the array up for the memory from 32 columns and 32 rows. And wherever there's a cross point, you can have a memory cell. So that's the secret to Intel's design of the 1103. Mm-hmm. Did you ever notice that in the story of the DRAMs, the RAMs, you never got a 2000-bit RAM. It was 1000 bits, then it goes 4000 bits. The reason is that the memory array starts out, the small one is 32 by 32. Now I want to make a bigger one. I'm going to do 64 by 64, 4096 bits. And I use that formula in the pub, in the honky-tonk bar, saying that is the way memories will go. Because I had to predict what technology would bring in order to design Teletext in 1971. And in the end, Teletext did sell to billions. I don't know how many countries used that. And you used to go to the shops, they all had the Teletext chips in. I believe, it sounds strange, but I don't know much about, because later on, do you know what headhunting is? Well, in the 1970s, Intel was going around the world headhunting people who had done something in electronics. And they came to see me every month, putting ridiculous offers on the table. So I became an Intel person. I'm sorry, but spent 20 very, very happy years at Intel.
Hmm. I guess the work pattern for you saying that you weren't really conforming with the regular 9 to 5 culture. A lot of these new companies, like from Sunnyvale and America, they sort of nurtured talent like that. From what I've read in the past, with like Atari and Moss, it was very the more non-conformist you were, perhaps the more creative you'd be when you were actually sleeping under the desk.
You are absolutely spot on. One of my bosses at Intel was called John Bayliss. He was the lead of the group that designed the 8086, which was a very important processor in Intel's history. And I was in his group for a period of time, and they employed 1 or 2 people. We get people coming out of Cambridge University and things like that. And one of these guys from Cambridge used to come into work with a tie on. And John Bayliss used to say, like, everybody in his group is compulsory, goes out for a beer. I maybe not saying too many things here on this, but everybody in his group must go out for a beer on a Friday afternoon. And so one day, whilst we're having the beer, he takes this Cambridge guy aside. He says, "Look, I don't mind what you wear at home, but please don't wear the tie and the suit at work, because it's putting off all my engineers." So, yeah, I fitted in well I mean, I had extremely happy days at Philips. I loved every minute. But Philips did not accept me the way I was, quite honestly. There were some times when I had to be the one to go on the customer visits, because it was going to be real technical, and they wanted me to do it. But Philips tended to hide me a bit. Intel, that's the man. Be like that.
Mm.
Yeah, Intel was jeans and casual. Yeah. But we were technical. We were technical people. We weren't like all my life I've been in laboratories. All my life. I always my hobby has been my work all my life. Except that the neural systems never really came to much. I've got them here if you send you a picture.
Oh, please, yes.
Stochastic neural systems. Stochastic.
Mm-hmm.
A way of multiplying with a AND gate.
Mm-hmm. So with the neuro systems, and obviously what we now understand as AI, you mentioned earlier that you went to Manchester, was it?
I went to Manchester University.
Yeah.
I did electronics, electrical engineer electronics,
Mm.
and then when I was in London, I think it was UCL. They allowed me to sit in on their psychiatry lectures.
Mm-hmm.
So I and a friend of mine, I had a friend in London, very, very, very clever fellow. Got the only first of the year at uni, the only first in electronics that year. He was very clever, very academic. I was not only naughty at school, at work. I didn't attend the lectures, but I passed. I got a degree. But my friend Jan, he was got the best degree, Norwegian degree, for 150 years. He was very, very bright, and he was my best friend. So the two of us used to go, I think it was UCL, and we used to sit on the psychiatry. It wasn't psychology in those days. They did psychiatry, so they were all doctors, and they were doing psychiatry. And I went there and I said, I was very interested in, and they let me sit on them. And every now and again, the lecturer would say, John, you're going to like this bit here, because they would be digging into more of the neurons rather than, like the psychology stuff. So I did that with Jan for several years.
Yeah, I believe it was at Manchester. Was that where, was that Alan Turing at Manchester with the pilot ace? I'm not...
Turing, yeah, Turing. That's where the world does not know this even now, but we're in a new industrial revolution. But this industrial revolution is not industrial. This revolution is information, an information revolution. And the industrial revolution basically replaced mechanical effort, mechanical effort by machines, like your hands, your legs, this information is going to replace our brains. The information revolution is all about information, and people talk in the AI world, they just don't know what they're playing with. This is very dangerous stuff, very dangerous. The early AI will be more clever than us, but I'm concerned about the AI that becomes sentient. When I started working on this in 1970, my interest was to understand what are the mechanisms that create sentience. I never succeeded in it, but because when I started at Intel, the reason I joined Intel was exactly the same as Philips. They offered me, quite honestly, ridiculous amounts of stock. But I didn't bother much about that. I would be much interested now, but not then. But I said, I will join you if you give me your DUF microprocessors, your DUF microcontrollers. And so we made this arrangement because when Intel produced the microcontrollers, a microcontroller has memory on it. It has RAM and it has ROM, or in the old days, this wonderful thing called an EEPROM. And they had a range of microcontrollers that I could use to simulate neurons. And so I made this agreement with them that if there was a defective microcontroller, for instance, maybe one cell in the EEPROM array was stuck high or low. But one cell stuck, the thing was scrapped. Now, it's very easy to design I used to do coding, right? Machine code, right? Very easy to make sure the one is a one. So I did a deal with them, and I ended up with their DUF microcontrollers. I have them here, thousands. But Intel was in Paris, based in Paris. So I got interested in other forms of mobile neural networks with two legs and female.
You'll never understand them.
No, yeah, absolutely
Mm.
impossible.
When you look at AI today, would you have envisaged when you were putting those chips together that we would be where we are so so quickly, or has it took longer than what you anticipated?
I'm very surprised how slow it's been, and mainly it's been slow because the microprocessors themselves were so successful at solving mankind's what, and a lot of the neural work was done on simulated neurons done by microprocessors, and it's only now that if you want to simulate a neuron, you don't want a big processor, a small one. So companies like Nvidia that made multiple processor arrays basically for video processing, wasn't for neurons, but they were perfectly adapted. They adapted perfectly to neural processing. But it is terrifying. Mankind will find that these AI systems are more clever than him. And then when I just don't know what happens when the neural system has feelings, it's happy one day and not happy, if it becomes sentient, if this mystery of how sentience is created by an electronic circuit, because the brain is no more than an electronic circuit, maybe with very low voltages, but it's electronics. And it can be simulated with bioelectronics perfectly simply. But to do it on the scale of the big brains is like a big deal. And NVIDIA right now makes that possible, makes the simulation. That's why what they're worth now, 3 trillion or so. Is it 3 trillion, I think? During my time at Intel, it went from a little company that no one had ever heard of to the one that has the modern world it's nothing to do with Microsoft or Google. It's Intel's chips that's made it work. And the invention of Bob Noyce, which is the chip. That's what our modern world is. And I know its power and its growth, and it's up like Gordon Moore's law. Like the complexity doubles every 1.5 years. It used to be 1 year. The information revolution, mankind's becoming aware of it. People at Intel were aware of it. Like they knew what they were doing. They knew that they were changing the world again. Maybe even more than the Industrial Revolution. The Industrial Revolution changed the world more quickly and more extensively than any time in human history. And over a period of 200 years, 300 years, the world just changed. The information revolution is going to do it even more, I think. And nowadays, if you look on the internet, you'll find people cite teletext as the world's first implementation of the information revolution. It's like, and it's the world's first widely used information system. And so as time goes on, it's going to increase in importance.
One of the biggest challenges I've found with my my interest in teletext is that I felt it was really important to speak to the people that were involved with it, because as the internet just harvests the information with the meta tags teletext and history, there's now concepts of teletext that never actually existed that get conflated because there's no verified sources. And I can imagine that happening in other things as well. But it was definitely a motivation of mine to get the actual source available before somebody does lazy journalism and just types it into a search bar and just basically just prints up what comes up at the top of a search result.
Well, I really admire your what you're doing, your ambition. I think it's really fantastic. It's been a concern of mine and a big concern of my family that I disappeared out of the teletext world, but I went to Intel and it was like it was fantastic. It was fantastic. I lived in a company that every year doubled in size, and then the people running Intel said, like, all we're doing is spending all our time training new people. We have to slow down a bit, calm down. And so Intel, but it was a very wonderful time, and I was living in Paris. Very nice, thank you. And they moved to Swindon. Intel Swindon is where I was moved. But I mean, the head office obviously is in Santa Clara. But they moved all the design group to Oregon. But no, they moved them to Oregon because the Intel engineers used to go out in Santa Clara that were doing the design work. And after 5 or 6 beers, we'd be chatting about the fantastic, whatever it is, like that they've dreamt up today, like, and there was someone from Motorola sitting there and maybe someone from TI over there. So they moved the design group to Oregon. So the farmer, he was talking about his tractor and his whatever he was digging, and didn't understand about the incredible multiplexer or whatever the Intel guy was talking about.
Yeah. Well, it's been absolutely incredible, and to know that, there won't be many people that will know that they created something in the very beginning that is still being used and is still an industry standard.
No, I don't count teletext. I count the fact it's the world's first major information system. That's what it is.
John Adams there. And once again, thank you to John for appearing on the podcast and sharing his account of the creation of Teletext. I hope you enjoyed listening to this podcast as much as I did making it. If you want to support the podcast in any way at all, please do feel free to share and like the podcast amongst other people. If you feel that way inclined, you can buy me a Ko-fi on ko-fi.com/BiteHigh. Any contributions just offset the costs of hosting the podcast, which of course is a hobby that I enjoy doing. Teletext People is produced by me, Carlos, and is a Byte High No Limit production. And remember, keep it blocky.
You're still here? It's over. Go home. Go.